So we spent a lot of time trying to unpack this precise definition of a limit. If you're a math major, you kind of want to at least make a great effort to try to understand it. If you're a business major, I can understand why you'd be like, why do I have to learn this? This is very out there. I want to remind you of how we did this case right here. So this is a line. If you look at this guy, this is a line. And notice how when we plug in a 1, you're going to get 4. So it's almost like we're trying to prove something that we already know is true. We're trying to prove something that's obvious. And what happened was we did it in 2 steps. The first step was just to find the delta. In other words, I let them squeeze epsilon, and then I want to know how much do I have to squeeze delta. And if you look, the delta that we ended up getting depended on what epsilon was. So in this particular case, I start off with the conclusion of my precise limit definition, and I work backwards to figure out what the x minus a was less than, and whatever number here, that's going to be my delta. So if I go back to my definition, we went backwards. We started with this tail part over here, and then we worked backwards and ended up over here. And then whatever the delta, whatever was on the right-hand side, we would call that delta. That's what happened with this guy. Writing the proof, all the hard part is number 1. Writing the proof is just writing the steps you did earlier in reverse. So the linear case is very straightforward. When I looked at your worksheet, most of you did not fill in this delta. You just kind of left it blank. You were supposed to kind of work things backwards like this to figure out what that delta should be. So some of you did it and some of you did not do it. That's fine. This is just more of a participation activity for me. So I think I should pause and let you ask me any questions before I try to prove 28. Does anyone have any questions? Oh, sorry, I saw a couple of things in the chat box here. Oh, I see LOL and haha, and I have no idea what that was in regards to. But did anyone have any questions for me about example 27 or anything I've said before? All right. I'm going to reiterate one more time. You're not going to be tested on this. It's more exposure. Okay. So let me do this example for you. This example 28. And then we're going to leave this. So Samantha asked a question. Is this essentially what we were supposed to do in the practice on the worksheet? If you're talking about finding out what this delta is, yes, you were supposed to kind of do just this side right here and figure out what that delta was, Samantha. Okay, so we're going to do the same method that we did earlier. So the first step was let's try to find delta. Okay, so what do we know here? We know that our f of x is going to be equal to x squared. We know that our L, which is what our limit's equal to, that's going to be 4. And we know that our A value, the point where we're taking the limit, is going to be 2. And I get that just by looking at this limit right here. This is the f of x, this is the L, and this guy is the 2. All right. Now, the way that I found it, my guess was I started off with the conclusion. So I started off with the absolute value of f of x minus L is less than epsilon. And remember, they get to choose epsilon. So epsilon is already given to me. Now I'm going to fill in the different pieces. So if I fill in the pieces, x squared minus 4 is going to be less than epsilon. I want to remind you, though, that we're trying to work the definition backwards. So at the very end, I'm hoping to get x minus a is less than whatever. with whatever's in that box will be my delta. Now, in this case, I just want to remind you, A was 2. So we're really trying to get here. That's kind of our end goal. So we want to go from there to down and figure out how to do that. Okay. Knowing that I ultimately want to get an x minus 2 here, does anyone have any advice for what I should do with this guy? Any advice? I agree, Cigar. I agree, Randy. Let's factor. So this guy's going to be x plus 2. Sorry. This is going to be x. This is going to be x plus 2 times x minus 2, like this. It's less than epsilon. And we have an absolute value around the whole thing. Now, when you have a product of two things, yes, Hao-Wei, that's right. You factor it in that way exactly. And then when we split this guy up, this becomes x plus 2 in absolute value and x minus 2 in absolute value, like this, less than epsilon. Now, for us to get from here, this step to this step, it's going to require something a little bit extra. And on that worksheet, you had like they tried to lead you through this a little bit, but they sort of had a very specific scenario there. I want to prove this to you in general. So what we really need to do, we want to keep the x minus 2 part, and we want to bound the x plus 2 part. To bound it means I want to say the biggest it can be is this. Okay. So how am I going to do that? What I'm going to do is I'm going to do something that's kind of interesting. I'm going to draw a little number line like this. This is my value of 2. That's the A. And what I'm going to do is I guarantee the biggest delta will be is 1. Now, you don't have to choose the number 1. You could really choose any number. But if you want to bound this guy, you have to make some sort of a guarantee about delta. And let me explain how that guarantee is going to work. Okay. If I say delta, the biggest delta can be is 1. That means the furthest I can go on this side is 3. And the furthest I can go on this side is 1. Okay. When I think of what f of 3 is, f of 3 is 5. So if I were to graph this guy, this is going to be a line, and it looks something like this, where this point right here is 3, 5, and this point right here is 1, 3. And what I want to do, this is the line y is equal to x plus 2. So remember, I'm trying to bound this term right here. So I'm trying to say, I want to replace this with a number, the biggest possible number. So from my point of view, I have two choices. I could replace it with 3, or I could replace it with 5. And I think I want to replace it with the largest number. So really, this part will be replaced with a 5. So I'm going to come over here. I'm going to delete this. I'm going to say, okay, this number is bound by 5, x minus 2 less than epsilon. Now all I got to do is divide both sides by 5, and I get x minus 2 less than epsilon over 5. So my delta is epsilon over 5. Almost. In reality, my delta is the minimum between epsilon over 5 and 1. And this is how you want to find the delta in this case. Okay. So epsilon delta proofs at the 5a level, they kind of come in two flavors. One flavor is this linear case, like number 27. And the second flavor is this example 28 case with the quadratic. Okay, so I think I'm just going to leave it here. Does anyone have any questions for me about this? Because I want to leave this now for the rest of the semester. All right. Cool. We have been talking about derivatives lately, and I wanted to show you something involving a derivative. So let me do that. This is not it. Hold on. Okay, so check this out here. The function that we're looking at right here is in blue. And when I move this A point changes where we're calculating our derivative. So if I move it right here, this is like a, let me put it at 1. Okay. Then this is our slope of our secant line. This H slider is the amount that we're adding. So if you look on the line below the H slider, that's our definition of the derivative. And what happens is as we move the H closer and closer to our A, our secant line becomes closer and closer to the tangent line. And right when they overlap, in this case, it's undefined. It's undefined because you have a 0 in the denominator. So when we're calculating our derivative, we're letting the second point move closer and closer to the first point. And then when they're equal, you're going to get the tangent line. And it has to be the same when you come from both directions. So this is what the idea of a limit is. And this is a picture of what's going on when we calculate our derivatives. If I switch to the tangent line example, here's the same situation, I think, or a similar situation. In this case, I can't move the second point. They're just giving me the tangent line. But I want you to notice that when I changed A, the tangent line changes. So when you look over here, if I go to the very top of the hill, what does it look like the slope of the tangent line is at the top of the hill? I can't do it. Can you use your imagination? What do you think the slope of the tangent line is at the top of the hill there? 0. Yeah, that's right, Samantha. I'm going to try to move it to the bottom of the hill. Here's the bottom of the hill. Oh, well, I hit it. There's the bottom of the hill. Look, that tangent line is definitely 0, right? If I keep going, I hope you can imagine at the top of this hill. Oh, I guess it looped around. At the bottom of this hill, it's also 0. At the top of this hill, the slope is 0. At the bottom of this hill, the slope is 0. At the top of this hill, the slope is 0. So there's a pattern here. Okay. Anyways, just I feel like we should use modern technology to help us understand what's going on with the slope of the tangent line, which is what the derivative is, as well as the tangent being a limit of the slope of secant lines. So was there any questions about that? Okay, great. So let's move on to 3.2 then. I hope you've had a chance to, or did anyone have any questions for me before we start 3.2? I wanted to say a lot of words here today, talk your ear off a little bit. But if someone had a question they wanted to ask, I'd be more than happy to answer it before I start 3.2.
For the proving question, how did you know which of the factors to keep and which one to bound?
That's a great question. Do you remember when I started talking about this? I started off starting with the f of x minus L. And then at some point, I just jumped down here like this. And when I filled in the A was 2. This told me, oh, I want to keep the x minus 2 factor, and I want to replace whatever other factor there is. So when I go up to where I factored it, I see one term is x minus 2 and one term is x plus 2. And by virtue of the fact that I want an x minus a at the end, I know I want to keep the x minus 2.
Okay. Okay, I see.
So if this question instead was the limit as x went to -2, then in that case, x minus a would equal to x minus -2, which would be x plus 2. So if they change the limit to go to -2, I'm no longer keeping this guy. I want to keep this one, and I want to bound the other one. Does that make sense?
Yeah, thank you.
No worries. I'm going to erase this part in case someone gets confused when they look at it later.